Today's lesson is 2.4 Angle Relationships. Please don't forget to get your notebook and copy down the title of today's lesson, the page number, mine happens to be 26, and of course today's date, it is the 15th. We're going to start off with some vocabulary. Please go ahead and copy this down in your notes. Two lines are parallel lines if they do not intersect and are coplanar. Remember, this is the symbol for parallel lines. Our new word today is transversal. A transversal is a line that intersects two or more coplanar lines at different points. Go ahead and pause the video to make sure that you have these two vocabulary words copied down in your notes. All right, the next thing that we're going to do today is we're going to talk about what the two parallel lines would look like. On the drawing here, if you could please copy this in your notes, you can see the two parallel lines would be line A and line B. They fit our definition from up above. I could also show that they are parallel by putting the parallel symbol on each of them, which you will see in your foldables today. We're going to talk about the groups of angles that are made, which would be angles 1, 2, 3, and 4 by the transversal and line A, and angles 5, 6, 7, and 8 made by line B and the transversal. Of course, this right here, this line T, is going to be my transversal. And what you're going to see today, as we talk about the transversals specifically, I will always be highlighting it in yellow. I know that this is the transversal because of the definition. Due to that, we have two different distinct pieces of our picture. We have the interior angles between our two parallel lines. So that would give us angles 3 and 4 and angles 5 and 6. These would be our interior angles. Please make sure you are that you are copying down this picture, as it will come in handy. Let me just go ahead and highlight the interior. We also have two exterior positions. The angles above angle line A and the angles below line B become our exterior angles. And of course, remember, exterior just means we're outside. So in this case, outside of what? We have to be outside of the parallel lines. So that would be above line A and below line B. There we go. And of course, as always, pause the video to make sure that you have your picture done. All right, we're going to go ahead and do our first foldable of the day. This would be the smaller foldable. Please go ahead and cut out on the solid lines and fold on the dotted lines. We're going to start with the complementary angles at the bottom of the foldable. Complementary angles are two angles with a sum of 90 degrees, as of course you saw on the front of the foldable. They can be what is called adjacent, which is when you see them drawn together and you see the 90-degree box marked, or they can be what is called non-adjacent, which means that they're two separate angles and they add up to the 90 degrees. 40 plus 50 is 90. Let's go ahead and take a look at our first example. LMN and PQR are complementary. So notice as we're reading right here, we see that they are complementary angles. This means that I know that they sum together to make 90 degrees. So I could go ahead and say angle LMN plus angle PQR equals 90 degrees. And I know this because of that first sentence, this first sentence right here. Find the measures of the angles if PQ, if LMN is 4x minus 2, and if PQR is 9x plus 1. So I could use my highlighters here to help me to substitute. Now I can tell very easily that 4x minus 2 is going to go right here, and that 9x plus 1 is going to go right here, equals 90 into my formula. The highlighting is not necessary, it just helps me to quickly substitute in my problem. All right, I got to get these x's together since they are on the same side of the line, right? The same side of the equal. I can go ahead and add them together. I'm adding them together because that is what's in between them. Remember, I pretend that these two don't exist, so I have 4x plus 9x, which gives me 13x. I can also go ahead and combine the negative 2 and the positive 1. Remember, in this case, I'm pretending that these don't exist. They are like terms since they do not, either one does not contain an x. Negative 2 plus 1 is negative 1. And now I have my two-step equation. Remember, the purpose of putting the x in the color is to tell your brain that you have to get rid of the 13 and the minus 1. And it helps also to say I have to get rid of the minus 1 first. I have to eliminate it to the other side by doing the opposite. There we go. And of course, you guys are all awesome at knowing that you have to divide as your last step. And here is our answer. Perfect. Let's go ahead and take a look at supplementary next. Supplementary angles are two angles with a sum of 180 degrees. They can be what is called adjacent, which would look like this. Please go ahead and add this to your foldable. Notice that adjacent angles do make a straight line, which we know to be 180 degrees. Or they can be non-adjacent. Notice in our two non-adjacent angles that they do tell us right here that angle A and angle B are supplementary. Let's go ahead and take a look at our example down below. The measure of the supplement of an angle is, notice I'm going to pause right here that I do see that word supplement. This means that they are supplementary, and I know that they add to 180 degrees. All right. Is 36 degrees less than the measure of the angle? Find the measures of the angles. All right, so what's happening here in this one is they are not giving us like the 9x plus 1 that we saw in the last example. So I'm simply going to go ahead and call them angle 1 and angle 2 because I don't know what to call them, right? They didn't give me a name like LMN or PQR. So I'm going to go call them angle 1 and angle 2, and I know that they have to add to 180 degrees because of that word supplementary. Whenever this happens and they're telling me it's 36 degrees more than or 36 degrees less than in this case, or it's 2 times or 2 times plus 1, anything like that, I'm going to go ahead and call angle 1 simply x because I don't know what it is, but I do know that in comparison to it, angle 2 is going to be 36 degrees less. Less than would imply subtraction, and I'm going to call it x minus 36. And now I know what to substitute in. If you want to use your highlighters, you can. You're going to substitute in x for angle 1 and you're going to substitute in x minus 36 for angle 2. So let's go ahead and do that. Once again, they're not necessary, the highlighting, it's just helpful. All right, there we go. Once again, notice that our x's are together on the same side, right? Notice they're together on the same side, so I'm going to combine them together. I'm going to pretend like this is not here, which would give me 2x and then minus 36. And now I'm going to go ahead and I'm going to solve this problem. Let me just go ahead and grab my calculator just to make sure that I do this correctly. Remember, we're always getting rid of that number after the x. So I'm going to go ahead and add 36 to the other side, which would give me 216. That's what I thought. And then, of course, I would end by dividing by 2. And I would get x is equal to 108. Now remember, you could also go back and substitute this in. Of course, that means that angle 1 is 108 because it's simply x. And then angle 2 would be 108 minus 36, which in my calculator is 72 degrees. So we would have 108 degrees and 72 degrees if we were to substitute back in. All right, let's take a look at our linear pairs. A linear pair of angles are two adjacent, so this time they must be touching one another because that's the difference between adjacent and non-adjacent, whose non-common sides form opposite rays. If you take a look at the picture, notice that this angle and this angle, these are the non-common sides that they're talking about. They do form opposite rays because they do form a straight line. Linear pairs are going to be supplementary, which means this angle plus this angle has to equal to 180. It's a very common misconception to say that this angle equals 180 and that this angle equals 180. That is incorrect. Together, they equal 180. Together, they equal 180. All right, so let's go ahead and take a look at our example. Two angles form a linear pair, so there's that word right there. We don't have to draw a picture. We use the word, it implies that they add together to 180 degrees. The measure of one angle is 3 times the measure of the other. Find the measure of the angles. So once again, I don't know what they are, but I'm going to go ahead and call them angle 1 and angle 2. And I know that they add to 180 degrees because they are a linear pair, which means they are supplementary. I can go ahead and call angle 1 x because I don't know what it is. And then I would say that angle 2 is 3 times it, which means I would call it 3x. Now I can go ahead and substitute, and if you want to, you can use your highlighter to help you substitute faster. So now you know to put in x for the pink and 3x for the blue. Once again, the x's are on the same side. If you need that visual, there you go. And so we're going to go ahead and do what we see, which is add them together. That would give us 4x. If you're wondering why I keep getting one more, remember when I just have x by itself, like right here, there is a 1 that is hiding invisibly in front of it. Since there's no adding or subtracting to get rid of, I'm going to go ahead and go straight into my dividing. and that's going to give me my answer. Oh, no. There we go, 45. That's what I was thinking. Just wanted to make sure. All right, and our final relationship between angles in our first foldable are vertical angles. Vertical angles are two angles whose sides form pairs of opposite rays or a pair of non-adjacent angles formed by two intersecting lines. This, of course, is the most common way to see vertical angles is my intersecting lines that you see here in this one, in this diagram. Vertical angles are congruent. That means that this angle here at X is 72 degrees. Notice that the angles in this picture only share the vertex. That's all they have in common. If I were to do angle X, it would be this would be its angle. And if I were to do the 72, this would be its angle. The only thing they have in common is that vertex in the center, meaning these two angles are equal. If you look at the other two sets of angles right here, they are also vertical to each other, meaning this angle here is equal to this angle here. Remember that when I use an arc mark and I use 1 and 1, it means that they're equal, and when I use 2 and 2, that means they are equal. If I wanted to show that these two angles were not in fact vertical, I would have to add a third line to show that it's a different degree. That is not the case, however. When they are opposite each other, they are congruent to each other. So let's take a look at our first example. Notice they're telling us ABC and DBE are vertical angles. So once again, not necessary for a picture, because I know that angle ABC is equal to angle DBE. And I know this from the fact that they are vertical angles. If I wanted to, I could go ahead and use my highlighter to help me out. I'm going to plug in this for ABC, and I'm going to plug in that for DBE. So let's go ahead and do this. -8. And let's solve this problem. Let me go ahead and zoom in for you. This time I notice that I have an X on both sides. This time I cannot add them together because they're on opposite sides. I have to move one to the other side. It doesn't matter which one I do. Doesn't matter. I can move whichever one I want. I just need to make sure that I only move one. Now it is common to move the smaller one, so that's what I'm going to go ahead and do. And of course, I need to move it by eliminating it because I'm moving from one side to the other. All right, now I'm going to go ahead and subtract. 7 minus 5 would give me 2. I'm going to bring down my -8, and I'm going to bring down on this side just the 10. Now I just have my two-step equation, and I know how to solve that. Eliminate the -8 by adding 8. Combining 10 plus 8 is 18. Dividing by 2. There's my answer. And of course, as always, if I wanted to know what each of the measures were, I could come in and plug that in. I didn't slide over enough. Now in this case, I should get the same answer when I plug both of them in because I did get vertical angles, which means they are congruent. All right, in our final foldable for today, there's no cutting needed. You're just simply going to go ahead and fold on the dotted lines. Please make sure that once you have finished this first foldable, that you do go ahead and get it glued into your notebook. All right, let's go ahead and start with the consecutive interior angles. The first thing I would like you to do is I would like you to add this to the top, because sometimes consecutive angles are called same side angles. And so I'm not sure what Delta Math is going to call them. So I want to make sure that you do know what Delta Math is talking about. So please add that to the top. And then of course, they're not just interior like the foldable talks about, they are also exterior as well. So if you could please go ahead and add that as well. All right, let's go ahead and open it up and let's talk about our consecutive interior angles. They are, of course, our interior angles, so consecutive exterior would be exterior angles, right? On the same side of the transversal, let's start by highlighting our transversal. Remember, the transversal has to intersect two or more lines. So these two lines have to be our parallel ones. They look parallel and they have the parallel symbol. So this line must be our transversal. We are talking about interior angles here. So we're going to go ahead and talk about this angle here and this angle here. These would be considered same side interior angles or consecutive interior angles. You also have them on the other side as well. I'm just going to go ahead and switch my color, and I'm going to put 2 dots to represent that they go together. So blue with blue, 2 dots with 2 dots, black with black, 1 dot with 1 dot. All right, and then of course for the exterior, imagine the black dots flipping outside. That's what same side exterior would look like on this side. And then of course imagine the blue dots flipping outside as well. Consecutive interior angles are what we call supplementary. So remember, this means that they add up to 180 degrees. So in my example, I'm going to notice that I have my transversal, and then I'm going to notice that these two angles right here would be the black dots from up above, meaning that I can go ahead and add them together, and they have to equal 180 degrees. Now I can go ahead and I can solve for x. Oops. There we go. All right, let me just go ahead and make that a color. And of course, we're going to go ahead and eliminate the 60 by doing the opposite, because we always get rid of our add or subtract first. There we go. And then, of course, we would divide. There's our answer. We can, of course, go back and plug that in. 3 times 40, 120, and we can check 120 plus 60, 180. We're all good. All right, let's go ahead and take a look at our next type of angles. These are our hardest angles. These are our hardest angles to do. So please make sure that if you have any questions that you ask. Okay, corresponding angles have corresponding positions relative to the transversal. All right, let's go ahead and let's start by highlighting our transversal. And then the next thing we're going to do is we're going to number our angles. So let's go ahead and number them like we did. like we saw in our first diagram that we drew. When we are comparing to talk about corresponding angles, we're always going to compare one of these to one of those. Once I put a box around the 1, 2, 3, 4 and a box around the 5, 6, 7, 8, I can start talking about their position. Notice that angle 1 is in the top left and angle 3 is in the bottom left. Angle 2 is in the top right and angle 4 is in the bottom right. I can do the same thing on 5, 6, 7, and 8. Top left, bottom left, top right, bottom right. So when we start talking about how they compare to one another, we're going to start talking about angle 1 is the same position as angle 5 because they're in the top left. Angle 2 is in the top right, so it would correspond to angle 6. Let's see, angle 4 is in the bottom right, so it would correspond to angle 8, and then angle 3, bottom left, would correspond with angle 7, bottom left as well. Notice this is one where we have an exterior corresponding to an interior angle, an interior corresponding to an exterior. So this is the only combination of where you're going to see one's interior and the other is exterior, just depending on their positioning within the group of 4. Notice that when we talked about the same side or the consecutive, they were both interior or they were both exterior. This is the only one where you have 1 and 1. All right, corresponding angles are, of course, congruent. Corresponding angles are, of course, congruent. Let's go ahead and take a look at our example. So in our example here, this, of course, is our transversal. We always start by making sure we know where our transversal is. And if I just zoom out a bit, I will notice that using the colors that I used up above, this angle and this angle would be my orange angles. This one is, of course, exterior. This one is, of course, interior. And that's a good indication. It doesn't always work that way, but it's a very good indication that it is a corresponding angle. All right, let's go ahead and solve then for x. We're going to go ahead and set these two equal to each other. And we're going to solve for x. Here we go. All right. Make sure you eliminate the addition first. And then do your division. Could we go back and plug it in? Yes, we could. When we plug it back in here, we should get that 2 times 31 plus 1 gives us an answer of 63. If it does not give us the same exact answer, then of course we did something wrong. All right, our last two angles to talk about today are alternate, interior first, and then exterior. Alternate means how we're going to move across our transversal. And then, of course, we're going to talk about where they are interiorly, and then we will talk about where they are exteriorly. I hope that's a word. All right. Alternate interior angles are non-adjacent angles. Notice they're not going to touch each other, non-adjacent, that lie between the lines on opposite sides of the transversal. What does that mean? Well, let's start by highlighting our transversal. Opposite sides would mean here and here. But remember, when we're talking here to here, we're within the same group of four. Wait. We're within the same group of four. So we can't talk that way. We have to, because remember, we must go from this group of four to that group of four. So we're not talking this way. We have to alternate across and slide down. So when we alternate, we're talking these two right here. So let me go ahead and highlight that. It would be this angle with this angle. And then it would also be, let me just grab a different color here, this angle with that angle. And I'm going to go ahead and put a second dot with that purple. There we go. If you want to, you could also go in and add your numbers. You could also go in and add your numbers, right? There we go. So notice we're talking only about the ones here on the interior, right? Only the ones here in the interior are the ones that we're talking about for this one. And so we're talking about angle 3 comparing to angle 6. Angle 4 would go with angle 7. No, 5, sorry. Let me make those two a little bit darker. There we go, so you can see them. And of course, congruent alternate interior angles are congruent. All right, let's take a look at our example here. In our example, of course, this would be my transversal. And if I use the same colors as up above, these would be the purple ones. This would be the purple for angle 4, and this would be the purple for angle 5, if I just use the same coloring from up above. Now I can go ahead and I can set them equal to one another. And I can solve. Nothing to eliminate this time, so we're simply going to go straight into dividing. I don't think that divides. Let me check really quickly here in my calculator, but I don't think 3 goes in there. No, it does not. So I'm going to go ahead and leave it as 139 over 3. You could also change it to the decimal. I have a decimal in my calculator. So we could leave it right there if we wanted to. All right, our final ones are alternate exterior angles. They're going to work exactly the same as our alternate interior, just on the exterior portion of our diagram. Alternate exterior angles lie on the outside of the lines. That, of course, means the outside of the parallel lines, which means we're going to be talking about the exterior angles this time. Exterior this time. And they lie on the opposite side. So they're going to alternate just like before. Remember, not this way, right? They're not just jumping across. They have to across and slide down to the opposite group of 4. They have to jump across and slide to the opposite group of 4. All right, there's our transversal. So if we're talking about our alternate interior angles, we're talking about this one to that one, this one with this one. And of course, if you wanted to add your numbers in there, you could. There we go. So we're talking angle 1 with angle 8, angle 2 with angle 7. Alternate in exterior angles are congruent, just like the alternate interior angles. There we go. Let's go ahead and do our last example. There we go. There's our transversal. And then if I were to use the same colors as up above, I have my pink and my pink. I'm going to go ahead and set them equal, and I'm going to solve for x. And of course, I'm setting them equal to each other because they are, I am recognizing that they are alternate exterior. In this case, I do have to eliminate the 1 by subtracting first, which does give me 2x is equal to 100. Then I'm going to go ahead and divide by 2, which of course means x equals 50. I could go ahead and check to make sure that I am correct by plugging it in here. 2 times 50 plus 1 should give me 101. Your assignment for today is in Delta Math. Also, don't forget to finish up your Carnegie Learning warm-up. I'll see you on Thursday.